All right, so today we are going to look at examples 5, 6, and 7. They're all a little bit different from each other as far as like how it's asking you to simplify, still using the same identities that we used yesterday. The main identities that you're really going to use are the reciprocal, quotient, and Pythagorean theorem. We're not going to use the co-function a whole ton. Even, odd will come up a little bit, but it's really those first ones that we talked about that you're going to use the majority of the time. So for example 5, it is just asking you to simplify, meaning like I need to condense this as much as I possibly can for these questions, and I know it does not specifically ask you to do this, whereas example 4 did. A good rule of thumb with simplifying is kind of always changing stuff to sine and cosine. Again, doesn't tell you to do that. It specifically says simplify by factoring, which we'll get to once we get to the actual factoring step. But a good starting point is if I have stuff that is not sine or cosine, to kind of change it to sine or cosine. It makes canceling things out a lot easier, instead of like having to work with tangent and know what happens. So plugging in all of your identities up front that you can. So I have simplified cosine times tangent minus sine times cosine squared x. The first thing in this that I'm going to change, and I notice, is my tangent value. I'm going to change using my quotient identities. So the quotient identity says tangent is equal to sine over cosine. So that's going to be my starting point. So I'm going to rewrite this with that identity plugged in. So that's all I did, was from there to there. From here, when I did that, I have cosine times sine over cosine. If you were to actually multiply that out, you'd have cosine times sine over cosine. However, thinking about cross-canceling, these cosine values can just cancel out. So now I'm just left with sine x minus sine times cosine squared. So this is your step right here when it told you to factor, that you are going to factor, meaning what do both of these terms have in common that I can factor out? So thinking about like your greatest common factor. In this case, they both have a sine value included in them, so I can factor out my sine value. So I'm going to rewrite this as sine on the outside of parentheses. You're thinking sine times what gets me back to sine, which will just be 1. And then I would multiply sine times cosine squared x to get back to sine cosine squared x. So that is my factoring step. From here, again, if I have something that has a square in it, that should kind of clue you in that you are going to look at your Pythagorean theorem identities. So it's kind of the one that we've used in example 4 yesterday in both of them. So it's the one that says sine squared plus cosine squared equals 1. Again, not really written in that format, but one of the things that we rewrote was that sine squared is equal to 1 minus cosine squared. So the 1 minus cosine squared is what I have. So I'm going to replace my 1 minus cosine squared with my sine squared. So from here, I now have a sine times sine squared x. It is understood that like if I have a sine by itself, or really if I have anything by itself, that it would have an exponent of 1. So whenever I go to multiply these together, your exponents are going to add. So sine times sine squared is going to give me sine cubed x. That is my answer to this. I can't simplify that further. Again, like, I didn't necessarily end up with just a sine by itself, but I ended up with the word sine by itself. So that is your answer to example 5. So moving along to example 6. This is so sorry. Probably the example that most of you are going to like the least. It's not super complicated. However, because it's fractions, what I mean by that is, if I'm looking at this problem, I have all sine and cosines. So there's nothing that I can change to get rid of the fractions. Because I'm adding them, I have to have a common denominator. Right now I don't have a common denominator. So in order to make that happen, my 1 plus cosine over sine, I'm going to have to multiply by my denominator over here. So this whole side is going to get multiplied. It's kind of hard to tell what that is. I'll rewrite it. So this whole side over here is going to get multiplied by your 1 plus cosine to make a common denominator. This side's going to get multiplied by this. This whole side is going to get multiplied by sine x, which is coming from my denominator on the other side. So whenever you do that, if I'm multiplying my denominator by something, I'm also multiplying my numerator by something. The downfall of that with these two numerators is I have 2 terms times 2 terms, which means I have to FOIL. So when I FOIL, I will end up with 1 times 1 is just going to give me 1. 1 times cosine will give me cosine. 1 times cosine again is going to give me cosine. And then cosine times cosine is going to give me cosine squared. Combining my like terms, and this is different than what we've done before because we haven't had this scenario yet, but I have a cosine plus a cosine. So this is going to actually end up with 1 plus 2 cosine x plus cosine squared x. So that simplifies into that. In my denominator, so I'm kind of done with that part. FOILed, combine like terms. So in my denominator, I have 1 plus cosine times sine. I'm going to just leave that as 1 plus cosine times sine for right now. Right now it's better to leave that apart than to actually like distribute your sine and rewrite it as sine plus cosine times sine. We just did that in the last problem where we ended up having to factor it out. So instead of multiplying it and then potentially having to factor it later, I'm just going to leave it factored in that format. So then looking at my other side, in my denominator, I'm also going to just leave it as 1 plus cosine x times sine x. Then in my numerator, I would have sine x times sine x, which is going to give me sine squared x. So right now, I just multiplied everything. I've done nothing else. Combining them together. So just rewriting it as one whole fraction. My two numerators are going to combine, and then I'm just going to write everything over my denominator like this. So from here, I'm looking to see if I can simplify anything really using my identities. So the first thing that I notice is I have a cosine squared and a sine squared. So these two things right here tell me with the squared part that I could potentially look at my Pythagorean theorem identities. So again, it's that same one that we've used several times at this point. But the Pythagorean theorem identity is that sine squared plus cosine squared is equal to 1, which is exactly what I have. So I'm going to change that to 1. I'm just rewriting everything else. In your numerator, you have a 1 plus 1 at this point, which I'm going to go ahead and combine together to give me 2. Okay, so combining like terms. From here, and you couldn't really do this without combining like terms first. I know it seems like we just added something and now we're going to factor it, but I had the 2 in front of the cosine already, so it wouldn't have worked if I didn't actually combine my like terms. So the top of this fraction, I'm going to factor, and I'm going to move over here. So, meaning 2 plus 2 cosine x. They both have a 2 in common that I can factor out. So 2 times 1 is going to get me back to 2, and then 2 times cosine will get me back to 2 cosine x. The biggest part of why I did that is if you now look at your numerator and your denominator, there is a 1 plus cosine in the numerator, and there's a 1 plus cosine in the denominator. I can now cancel them out. So I now have 2 over sine x. Looking at your answer choices, that's not an answer choice. This doesn't specifically tell you to write your answer in sine or cosine form. One of the things, and we'll see this in example 7, but one of the things that you should have noticed up to this point, unless it was like example 1 or 2, where it was actually solving something with actual numbers versus now we're just like solely using identities and not dealing with numbers, is none of my answers are going to be in fraction form. So if I have sine in the denominator, I'm going to think about how I can move that to the numerator. This is where your reciprocal identities are going to come into play. So thinking about reciprocal identities, the reciprocal of sine is cosecant. So when I'm doing reciprocal, I'm moving it to the top, but when I move it to the top, it's ultimately becoming that reciprocal identity. So when I move my sine to the top, it's really going to become a cosecant value because of my reciprocal identities. So your answer to this would be part D, which is 2 secant x. So a little bit of a longer one. You will not have a ton of these, but if it's a fraction and you're adding or subtracting, remember you have to have a common denominator in order to actually add or subtract them together, which is kind of a pain in the butt on these questions, but it's what you have to do to get to your end result. Okay. Example 7. So example 7 tells you specifically to rewrite your expression so it is not a fraction. So my biggest goal in this question is to not have a fraction. So again, I have 1 plus tangent squared x over cosecant squared x. If I see a 1 plus or minus something that is squared, so my numerator that I currently have, that always points to your Pythagorean theorem identities. So looking at your identities, one of your identities that includes tangent is tangent squared plus 1 equals secant squared. So I have 1 plus tangent. I know it's not written in the exact order. Remember, order of addition doesn't matter. So 1 plus tangent squared is the same thing as tangent squared plus 1. Either way, I'm going to replace the top of this fraction with that identity and write it as secant squared x, and then leave my cosecant x in my denominator. So far, all I did was look at my numerator and change it using my Pythagorean theorem identity. So from here, I still have fractions. So what I currently did was to just simplify something and really get rid of the tangent. Looking at this, the only identities that you really have that deal with fractions, your reciprocals have fractions in them, and then your tangents are quotient. Quotient is division, which is ultimately a fraction. So those are the two that I'm going to kind of work with to get to my end result. So, looking at your reciprocal identities, secant is the reciprocal of cosine, and then cosecant is the reciprocal of sine. Where that helps me is, and I know I'm about to make another fraction for a second, however, we will eventually get rid of the fraction. Instead of having secant squared x, I'm going to change this, like just this top part, I'm going to be able to rewrite as 1 over cosine squared x. So cosecant and cosine are reciprocals. Sorry, I think I said cosecant. Secant and cosine are reciprocals of each other. So I can rewrite secant like that. Cosecant in my denominator is the reciprocal of sine. If I have it in the denominator and I go to do a reciprocal, it's really moving to the numerator. So this bottom part, I'm actually going to rewrite as sine squared x over 1. If I were to multiply that together, I would really just end up with sine squared x over cosine squared x. So you can really, I wrote it out so you could see what the reciprocal does. You can really just go from this step to this step. If you know secant is cosine, it's going to move to the bottom. Secant, cosecant is the reciprocal of sine, it's going to move to the top. So from here, again, I still have a fraction, haven't really helped myself get to the end goal. But if you are looking at your list of identities, one of your identities is your tangent identity under quotient. So under quotient identities, it says tangent is equal to sine over cosine. So I have sine over cosine. I specifically have sine squared over cosine squared. So this is going to be one of my quotient identities. And I know that it said this. That is the identity that I'm going to use to get rid of my fraction. So if it is sine squared over cosine squared, instead of just one tangent, this is going to become tangent squared x, which is your answer. So I did multiple things to get to that answer. My goal is really to use identities to be able to change stuff. So again, it doesn't tell you to use sine and cosine, and my answer doesn't have to be sine or cosine, but this is kind of the easiest way to work things out. Is I ultimately changed tangent to secant, then I changed secant and cosecant to cosine and sine. Cosine and sine are a little bit easier to work with until you actually get to your final answer, depending upon what your question looks like. So, looking at one more with example 7, same kind of process, just your answer is going to look a little bit different on this question. So, your scenario again has a fraction. It's telling you get rid of the fraction. You already, in this case, have a sine and cosine to start with. So there's nothing that really helps you as far as like it's already in sine and cosine. I can't change it to sine and cosine because it's already that. The first thing that I notice is the sine squared x in my numerator. Again, if I have anything that's squared, that should automatically tell you to look at your Pythagorean theorem identities. So one of your Pythagorean theorem identities is sine squared plus cosine squared equals 1. Again, it can be rewritten, and one of the ways that we rewrote that was sine squared is equal to 1 minus cosine squared. So we're actually going to change the top of this to 1 minus cosine squared x, and then I'm going to leave the bottom of it unknown for a second. So that's my Pythagorean theorem identity. Now, looking at your top and bottom, please remember, in order to cancel stuff out, they have to be exactly the same. Meaning, I have a 1 minus cosine squared and a 1 plus cosine squared. They are different operations. I cannot just cancel them. Yes, that would be very easy. However, not how that works. But this top part, I can factor. The reason I know I can factor it is I can take the square root of 1, which is just 1, and I can take the square root of cosine squared. So it's been a hot minute since we've looked at factoring, but this is one of your difference of squares, which is where that's coming from. Difference meaning subtraction, square meaning I can take the square root of both of them. So my numerator, I'm going to break apart into 1 cosine x times 1 plus cosine x. So some of you will remember, like if I have a difference of a square of like x squared minus 81, I would factor this as x minus 9 and then x plus 9. It's kind of the same process of this. It's just I have a number and a letter, or like an actual word. So that's where the plus and minus comes from. Then I'm going to rewrite it as 1 plus cosine x. Now that I've done that, you will see that there's a 1 plus cosine x on the top and the bottom. So I can cancel those out, and I'm left with 1 minus cosine x. That's not a fraction, which is my goal, so my answer would be C.